How's it going, everyone? This is a free video from the coding interview course that I released earlier this year, Interview Espresso. This one's about binary trees. I hope you
Welcome back to 006. Today we are doing some of the coolest data structures we will see in this class, maybe some of the coolest data structures ever. Binary trees. You've certainly seen trees in many forms in the past, including in this class we've used trees as a lower bound tool for in the decision tree model. But this lecture and the next lecture, we're going to build one data structure that is almost superior to all data structures we have seen and can do almost anything really fast. First, recall all the data structures we've seen so far: arrays, linked lists, dynamic arrays, sorted arrays, hash tables. And the two sets of operations we're interested in supporting, the two interfaces, one was sequences, where we're maintaining items in a specified order. We want to be able to efficient means logarithmic. So we're not quite as good as linked lists and dynamic arrays at inserting and deleting at the ends. Those there that we achieve constant or constant amortized time. But up to this log factor, we're going to get the best of all worlds, where we can solve all the things, all the operations that don't build or iterate through the entire structure. That, of course, takes linear time. But we can do inserting and deleting. But they're really bad at find previous and find next. This is the unsuccessful case of and it's not in my structure. I would like to know more than just the answer no. I'd like to know what the previous and next item. The previous is just, I'm going to talk about node.left is a pointer to the left, the node down here. Node.right, node.parent, node.item gives me, so if I look at the node A, its item is A. So let me draw for you some examples. But there you go. Then for B is E, and so on. Okay, so in other words, each of these lines is a bidirectional pointer, which for linked lists was the head. If it's doubly linked, okay, I can have a head and a tail, and I can put bidirections on here, but then still the middle item has depth linear. So there's no, or the subtree of B is this portion of the tree. So it's that node and all of the descendants of this node. So because we have parents and children, we can generalize in the familial tree sense. We can talk about ancestors of a node. So the ancestors of F are its parents. Here you only have blown in the wind. So maybe I'll write some depths. Length 2. A similarly has height. We want to avoid these, but we won't worry about that till next lecture. Question?
That's my question. Is the height of node C 0?
What is the height of node C? Height of node C is 0. Because the length of the longest path, the number of edges in the longest downward path is 0. Yeah, we're counting edges, not vertices. Yeah. So the height of the tree is, of course, just the depth, the maximum depth. I think that's right. So the height here is 3, and the maximum depth is this terribly drawn 3. So these happen to correspond in the maximum case. Example first. Comes earlier. In fact, all the things in B's subtree come earlier or equal to E. So we have to keep going up. And then it turns out the successor of E is A, because this subtree was the left child of A, because B was a left child of A. So the general strategy is walk up the tree until we go up a traversal whose reverse direction would be left. Okay, so walk up the tree. When I say walk up, I mean node equals node.parent iteration. Until we go up a left branch. this would mean that node before, after, new is a new node that does not yet exist in the tree, hence I call it new. And what I'd like to do is insert, and then successor tells us where the successor is. It is the first node, which is the leftmost descendant, in the right subtree of the node. Okay, a lot of pointers to follow in that sentence, but new. Here. Put new there.
Hi guys, and welcome to my channel. In this video you will learn about tree data structure.
This course will help you learn what you need to implement graph algorithms and use them to solve
coloring. I have colored the full region that a depth first traversal would explore starting at A. Notice that if you started at A, it would be impossible to reach F. And that's kind of normal, right? That's kind of why we use the C. Then I should push B to my Q first, right? So I add B to the back.
Now let's create the add vertex method. And all we're creating here is this. In the next video, we'll create our add edge method, and then we'll be able to do things like this. But for now, this is all we're creating. So when we add the first vertex into the graph, it's going to look like this. So let's bring this down here, and we'll create this. So we're going to say class graph. So the first thing we need to do is create a constructor. So I added this into the add vertex method because this is a pretty simple constructor. So it'll be like this, and then we create a dictionary. I'll call mine adjacency list, and it's just an empty dictionary. So it didn't make sense to create a separate video for that, so I went ahead and just added it here. But what that creates is this. And then the add vertex method is going to be the part that does this. So now let's create that method. So we'll say add vertex. and we're going to pass it whatever value we want that vertex to have. Then we'll add that as a key to our adjacency list and set it equal to an empty list. But there is a step we need to do before this line of code, because we don't want to have duplicates in our graph. So to walk through this line here, if vertex not in self.adjacency list dot keys. In other words, if the vertex isn't already in our adjacency list, only then are we going to add it. And then we'll return true that we were able to add that. And if this if statement equates to false, we'll bypass all of this. And return false. All right, now let's go look at this in VS Code. So there is our class graph, and this is our constructor here. I also created a method to be able to print out the graph here. And this is the add vertex method that we just created. So I'm going to scroll this up. And this is where we create our graph. We'll call it my graph, and then we'll say my graph dot add vertex with the letter A. And then with this line here, we will print out that graph. So I'll run this. And you can see our new vertex A with an empty list. All right, so that is our method. For add vertex. So now let's create our add edge method. I'm going to bring up a couple of vertices like this. We're going to represent them like this, and we're going to connect these two vertices. And we're going to do that by doing this. So let's move this down here and start writing our code. We'll say add edge, and we're going to pass it vertex 1 and vertex 2, the two vertices that we want to have an edge between. So to connect these two, we will say first self.adjacency list at the vertex of 1. Remember, the value there is a list, and on that list, we are going to dot append vertex 2. That's going to look like this. And then we'll do it the other way. On this one, this is vertex 2. We're going to do a dot append onto that list. We'll append vertex 1 like this. So this is only something we want to do if both vertices exist. So let's say we're trying to do an add edge between the vertices 1 and 3. Well, we don't have a 3 vertex, so we can't add that edge. Both of these have to exist. So above these two lines of code, we will need an if statement. And this one's kind of long, but it's not complicated. So this is basically saying if vertex 1 and vertex 2 both exist, then we can create an edge between them. And when we do, we'll return true. If either one of them don't exist, this if statement will equate to false, and we'll skip past that, and then we'll return false. All right, so let's go look at this in VS Code. So there is our add edge method there. And this creates our graph called myGraph. And then we'll create two vertices, 1 and 2. And here is where we'll add an edge between those two vertices up the graph. Okay, so that is our method for add edge. So now let's remove an edge. We'll bring this up, and removing an edge is removing that white line at the bottom between the 1 and the 2. And then, of course, what it's really going to look like is us doing this. So I'm going to bring this down to the bottom. I'm going to bring these back because this is what we need to remove. And we'll start our method like this. And we'll pass it two vertices that we'll call vertex 1 and vertex 2. And then we'll do this at that key of V1, which is going to be 1. We want to remove the vertex of 2 like that. And then we'll do that on the other one as well, where we remove vertex 1 like this. So we can only do this, though, if vertex 1 and vertex 2 both exist. So we'll need an if statement. And this basically says if vertex 1 and vertex 2 both exist as keys in the adjacency list, then we can do these next two lines. And if that conditional in the if statement is true, after we run these two lines, we will return true. Otherwise, we will return false. So we'll take a look at this in a moment in VS Code, and when we do, we're going to build this graph, and then we'll remove the edge between A and B just like that. All right, so let's flip over to VS Code. So there is our method there, and this creates our three vertices A, B, and C. This connects them all together, and then down here we will print this graph out. So I'll run this, and that gives us our graph with A, B, and C, and they are all connected to each other. So I'm going to come down here, I'm going to paste this line in to remove the edge between A and B. So now I'll run this again, and you can see up here that the edge between A and B has now been removed. But the code as it is written here does not address one of our edge cases. And to show you what I mean, as it is written here does not address. So this was our original graph. Now we're going to create a graph that looks like this. I'm just going to add a vertex D, but it will not remove edge between A and D. Yes, I'm just going to add a vertex D, this is the same method up here. The only change that we have on this page versus what we saw before is we added the vertex D here. And then down here, the remove edge is between A and D instead of A and B. So I'll run this, and now we get this very long error. Okay, so I'm going to move this over so we can see this a little better. But you can see the problem here was with remove edge here, and then the error itself is a value error. So remember value error, we'll be using that in a moment. And the reason for that is it says list remove X. It is not in the list. So let me pull this back over here. So when we try to run this line right here, it said line 24 was the problem. We're trying to remove an item that is actually not in that list. So now let's flip back and look at how to fix this. So that is our method so far. What we need to do is this. We'll put a try in right here. So we're going to try to run these two. But in case we get an error, and specifically remember it is a value error, we want to decide how this connects them all together. And then down with A, B, and C, you can see up here, address one of our edge cases. And to show you what I mean, we're going to flip back. So this was our original graph. Now we're going to create a graph that looks like this. I'm just going to add a vertex D, but it will not have any edges with any of the other vertices. Then I'm going to run remove edge between A and D. So to look at that, let's flip back over. to VS Code. So this is the same method up here. The only change that we have on this page versus what we saw before is we added the vertex D here. And then down here, the remove edge is between A and D. Using that in a list. We try to run this now. That is our method so far. What we need to do, run these two. But in case we get an error and specifically remember, it is a value error. We want to decide how Python is going to handle this. So all we want it to do is ignore the error. So we'll say pass. And pass basically says ignore this and move on. And it moves on to the next line and returns true. So now let's flip back over and look at this in VS Code. So there is our new and improved remove edge method where we have our try and accept. And I'll scroll up here. And this is absolutely identical to what we saw before where we had the D vertex, and then we're going to come down here and try to remove the edge between A and D, even though D does not have any edges with any other vertices. So I'll run this, and now you can see that the code will run. Okay, so that is our method for remove. Now let's create our method to remove a vertex. So let's bring this up. We're going to remove the D vertex. But before we can remove that vertex, we have to remove all of the edges that vertex has with other nodes. And it is only then that we can remove the vertex. So let's bring this back, put our edges back like that. And this is what that graph will actually look like. So I had mentioned in the Big O video that there would be an efficiency that we could use in graphs that have bidirectional connections. And the efficiency is contained in this list. We know that if D has an edge with another vertex, that vertex also has an edge with D. So for example, right here, this edge that D has with A lets us know that A also has a connection back with D. So in a moment, we're going to create a for loop that just loops through this list. And the variable we'll use in the for loop will be called, in this iteration of the for loop, other vertex is A, and we'll go through its list of edges and remove D. We'll cycle through the for loop again. Other vertex is B. We remove D from that vertex, and then we'll do that for C as well. And now that we've removed all the edges, we can come down here and remove this vertex. So let's say we had a situation where the graph had 1,000 vertices. We would only have to go to these 3 to remove edges with D. And that is a huge efficiency. So our graph now looks like this. We've removed the edges and we have removed the node. Okay, so now let's start coding this. We'll say remove vertex and we'll pass it the vertex that we're going to remove. And the first thing we need to do is make sure that vertex actually exists in our graph. And if it does, we will use this for loop to go through that list of edges associated with D. So then we'll go to that other vertex and remove the edge it has with the vertex that we're trying to remove from the graph. Okay, so this part here, once again, is going to do this. Other vertex is A. We remove the edge. And then we're just looping through this list of edges. Now that we're done with this, we can remove the vertex itself. We will delete the vertex D. And that's going to look like this. D itself. We will delete the vertex D. And that's going to look like this. And now our graph looks like this. We do still have a couple of lines of code to add. If we have gone through this whole process here and removed all the edges, removed the vertex, we will return true. If the conditional in this if statement equated to false, we will skip all of this and return false. So we'll look at this code in a moment in VS Code. And when we do, we will build this graph, and then we will remove D, and then we'll print it out. And when we print that out, it should look like this. All right, so let's flip over to VS Code. So there is the remove vertex method there. And I'm just going to scroll this up, and then I'll move this over so we can zoom in on this. So we'll create a graph called My Graph. And these lines here create our 4 vertices, A, B, C, and D. And these create all of the edges that we had in the diagram. And this will print out our graph. So I'll run this. And that gives us our graph before we have run the remove vertex method on the D vertex. So I'm going to come up here. I'm going to paste in this line of code. And that's what's going to remove our D vertex. Then we will print this again, and D should be gone, as well as any edge that connects to D. So I'll run this. And this is exactly what we would expect. All right, that is our method for remove vertex. Now let's look at recursion. And if you haven't seen recursion before, this is a topic that typically takes a few times looking at this for it to really start to click. So what is recursion? My favorite definition of recursion is that it is a function that calls itself until it doesn't. So now let's look at a very common example that's used to explain recursion. I'm going to bring up a gift box here, and we need gift boxes when we run the open gift box, or it's going to contain is with the open gift box function. That gift box is either, again, back, and we'll look at some code. Now I want to emphasize this is pseudocode. This is not, so we're going to create open. When we open the box, it contains a ball. So if ball, we will return that ball. Otherwise, it's a gift box and calls itself. So there are the process of opening each new the same. This is a this box contains a ball. We will not the ball. This is what we call our this if statement is true. At some point obvious that the if you have something like this that you have the return statement in your code. So now the next thing we're going to look at is the call stack. And I'm going to start out explaining the call stack with functions that are not recursive. This is happening on the call stations. So whatever function is at the top of the call stack. So let's take this frame here and move it to function 1, and all it does is print out a string that says 1. Function 1, when you call it, will be put on the call stack. It will print out that string, and once it's done running, we'll remove this from the call stack. So let's bring this back and look at something a little bit more complex. Let's say that function 1, before it prints out this string, calls function 2. When function 1 calls function 2 gets pushed on to the call stack. But let's say function 2 is going to call function 3. That will cause function 3 to get pushed onto the call stack. And then we'll say that function 3 doesn't call any other functions. It's just going to print out the string 3. So this gets printed out like this, and once it does that, function 3 is done running, and we can pop that from the call stack. And now function 2 is at the top of the call stack again. Function 2 was waiting for function 3 to finish before it could go to the next line in function 2. So now function 2 can print out the string 2. And once it does that, we can pop function and print out this. But it printed out 321 because 321 is the order. And let's go look at this code in VS Code. This middle here where it says function 1 number, and then up here we have variable, current file is chosen. And next to that we have the green play button. I'm going to click, it becomes a bright red dot. That's going to create a breakpoint, and you can see that down here. And so I'm going to close, make sure it says Python and choose, just make sure Python current file is highlighted. That will be the next line, a downward pointing arrow here, and it says step into. This is what I'm going to use to step through this code, how it's going to print out. So I'm going to click on this. And now function. So I'm going to click on this. 1 from the call stack. So our debug con is our overview of. So now we're going to use recursion to solve a factorial. And factorial is something that is used to teach recursion in pretty much n equals like this. This is 4 factorial. And 4 factorial is 4 times 2 to teach recursion. So 3 times 2 times 1 would be equal to 3 factorial. So you could say that 4 factorial is equal to 4 times 3 factorial. And you could say that 3 factorial is equal to 3 times 2 factorial, and 2 factorial is equal to 2 times 1 factorial, and 1 factorial, well, this is our base case, so this one's going to be different. 1 factorial is just going to be 1. A couple of videos ago, we talked about a couple of things that you need to have in a recursive function. The first is that you need to be doing the same thing over and over. Down. The other thing is that the problem needs, we'll walk through it. So this is our recursive function for factorial. We're going to pass this a number in. In this case, we're going to pass it the number 4. Then we're going to check to see if n is equal to 1. When we get to the point where n is 1, we're going to return 1. If n is not equal to 1, we'll come down to this line here, where we return n times factorial of n minus 1. So this is where the function calls itself. So in this first iteration, it would look like this. We're going to return n, which is 4, times factorial of n minus 1. n minus 1 would be 3. So let's move this function up to the corner like this, and we'll walk through this. So first we have factorial of n. n is equal to 4 to begin with. And we'll say, is n equal to 1? Well, obviously it's equal to 4, so it's not 1. So we will return n times factorial of n minus 1. So we can do this, and we'll populate that with 4 and 3. So now we're calling the function with n being equal to 3. So when we run our if, is n equal to 1. It is not. So that causes us to run this line here. And this is going to be 3 and 2 this time. So we're running factorial on 2. So now our if statement is n equal to 1. It's not. So we have to run this line again. And now we're going to use 2 and 1. So we're running factorial on 1. So now when we say if n equals 1, it is going to be true. And we're going to return 1. That is this 1 here. So now let's just look at these lines here. Let's spread these out. And when we return the 1, we're returning the 1 to this function call here. And then we're going to return 2 times factorial 1 to this function call, and so on up the line until we return the answer to this line here. So let's walk through what this is going to look like. So when we return 1 there, we're returning 2 times 1, which equals 2, up to here. Now we're going to return 3 times 2, which equals 6, up to here. Now we're going to return 4 times 6, which equals 24. up to here, and factorial of 4 equals 24. So now let's look at this a different way. Let's use the GIF boxes that we used a couple of videos ago. So we start out with this being factorial of 4, then 3, and 2, and 1. And in the GIF box video, we had a ball when we reached our base case, but now this is going to be a 1. And then 1 gets returned to this function call, and then we have 2 times 1 is 2, gets returned to this function call, 3 times 2 is 6, like that, and then finally we get to the 24. And now let's look at this yet another way with our call stack. We start out with factorial 4. That goes onto the call stack first. Then we have factorial 3 gets pushed onto the call stack. And then 2 gets pushed onto the call stack. And then 1 gets pushed onto the call stack like this. And it's only that last instance of the factorial function that can run because it's at the top of the call stack. So remove that, and then we can calculate the next one like this, and so on until we get to here, and then we return the 24. So now let's go look at this in VS Code. So there is our factorial function there, and then we'll call it here factorial 4 and print out the result. And just like we did in the last video, we're going to come up here and open this run and debug side window like that. And then over here, we're going to click on the 3 dots. And we're going to choose the debug console. And next to this line, we're going to click the red dot, highlight that to create a breakpoint. Up here for run and debug, we want Python current file to be here. And if it's not, do the little drop-down menu, make sure that's selected. And we'll click on the green play button, and now we can walk through this step by step. So now when I click on the step into, it's going to run factorial, the factorial function, with the value of 4, and that gets pushed onto the call stack. It's going to check to see if n is equal to 1, and obviously it is not. So it's going to come down here, and when I click on this again, it's going to push factorial onto the call stack again, this time with the number 3. So notice that both functions on the call stack and then over here, we're going to click on the 3 dots, and we're going to choose the debug console. And next to this line, we're going to click the red dot, highlight that to create a breakpoint. Up here for run and debug, we want Python current file. And now we can walk through this step by step. So now when I click on the step into, it's going to run factorial, the factorial function, with the value of 4, and that gets pushed onto the call stack. It's going to check to see if n is equal to 1, and obviously it is not, so it's going to come down here, and when I click on this again, it's going to push factorial onto the call stack again, this time with the number 3. So notice that both functions on the call stack are named factorial. And that's why I did the call stack video I did in the last video. It's easier to keep track of this and kind of see what's happening when the items on the call stack are called function 1, function 2, function 3. In a recursive function, it's just going to be called factorial because it's calling itself. But these are distinct instances of factorial. So I'm going to come up here and we'll step into this again. The if statement is going to be false because n is not equal to 1. We'll come down here. And now we're going to get another factorial pushed onto the call stack over here. You can see we have 3 of them now. This latest one is with the number 2. N is still not equal to 1, so we're going to come down here again. And now it's going to get pushed onto the call stack with the number 1. Now we have 4 factorials on the call stack. But this time, n is equal to 1, so we come down to the return 1 here. And when it returns that 1, it's going to pop one of those factorials off of the call stack. So I'm going to click on this, and you can see that we only have 3 factorial functions on the call stack now. And as I showed before in the animations, it's returning it here. It is returning it to where this was called with the number 2. So when I click on this, that's going to get popped from the call stack. And this is going to be with the number 3 and with the number 4. This will be the final one that gets popped off the call stack, and it's going to return that value to here. And so for this last one, I'm going to move over from the step into a couple of buttons over to where it says continue. And when you click on this, it'll just run the rest of the code. And I'm going to do this because there's a message that will pop up otherwise. So I'm going to click on this, and you can see that we have the number 24 that's been returned. And that is our recursive function for factorial.
In this video, I'm going to explain all the